focusing on ergonomics. So ergonomics focuses on designing our workspaces, furniture, and equipment to support health, safety, and improve productivity of office workers. It is also a method of evaluating how you do your work to identify any risk factors you might be subjected to that might lead to injury, and then finding the best solution to eliminate such hazard, or at least manage it. Okay. So what are ergonomic conditions? These are disorders of the soft tissue, specifically tissues around the muscles, the tendons, the ligament, joints, cartilage, and blood vessels and spinal disc. What are the possible causes? Possible causes include awkward posture when walking, repetitive exercise, like, you probably have to hold your mouse all the time. So that's repetitive. And your computer and desk at unsuitable height, probably your seat is too low or too high for the table on which you place your computer. Then improper leg position, like we are seeing here, hunched back when working on the computer, strained neck. These are the causes of disorder of the tissue disorder. For computer ergonomics, it just means that you have to sit with a proper posture along with periodic breaks to stretch and to walk to promote physical well-being. And here we have what we need to take notes of when working on the computer. Your head has to be leveled and balanced, generally in line with the torso. Your upper body, which include your shoulders, must be relaxed, your upper arm loose. And for your lower body, your lumbar spine here has to be balanced and supported on padded cushion. And your leg has to be parallel to the floor. Your thighs supported, as the case may be. Your feet are flat on the floor, or if you're using a footrest, you have to ensure that your feet is flat. And then for hand and wrist positioning, make sure that your hand, your wrist, and your forearm are straight and about parallel to the floor. Here is just a checklist of what we need to take notes of when we are working on the computer, in the office, or anywhere we are. We have to look at your head, check your neck, that your neck is upright and you don't have a hunched back. Your elbows are parallel, like what we are seeing here. Your chair is adjusted to the right position. If you have working with a document, probably you have a document holder in place. Your keyboard, all of them, your mouse has to be parallel. And when you're your hand has to be parallel to the mouse and the keyboard. And your chair height has to be appropriate, adjusted to the right level. And most importantly, remember to take breaks every 30 minutes. And here is just showing what is acceptable and what is not acceptable. For here is a wrong posture. We can see the upper body is bent, giving a kind of hunch back. The wrist is inclined at an angle. The legs, not parallel, just not straight, kind of at an angle also. And here is an healthy posture, the right inches away from the screen, proper chair support, relaxed wrist angle, and then armrest support elbows and wrist height. Thank you very much.
Thank you.
Thank you so much, Kemi, for that wonderful lessons that we learned there. Thank you so much. God bless you. Okay,
thank you.
So Jerry, go back. You can share your screen and so we can continue.
Okay. All right. Okay. Okay.
No, go back to the slide after Kevin.
Okay, the slide after Kemi. Okay. All right. That is it.
No, not here, not here.
Oh, sorry. Okay, your slide, yeah.
Exactly.
Okay.
So I welcome everyone on this call. Thank you so much for joining us today for joining Warri NAPE technical to business meeting. NAPE has put all this technical meeting together for knowledge sharing and avenues for us to be able to present our industries to academia achievements in geoscience and related disciplines. So I appreciate our NAPE president for joining on time too, and our president-elect, our NAPE president Biodun Ogujobi, FNAPE, then President-elect John Bosco Uche, FNAPE, all the ESCO members that are joining and they will also join in, fellows, BOT, whatever they call. We appreciate you for making our time to join Warri technical meeting. Thank you so much. We appreciate the speaker also for finding time to join this meeting to be able to speak on this occasion. Thank you so much. And the chairperson, Dr. Doris Akowa, and our speaker, our chairperson, will be joining us from US. Thank you so much. We appreciate you. So on the call, I think we'll call the president next to give us his opening remarks. So I appreciate that everyone, as we go on with the presentation, you can ask your questions, you can make your comments and all that. We're here to learn from each other. Thank you. Mr. President, your remarks.
Okay, thank you, Prof. And good afternoon, everyone. I hope you can hear me.
Yes.
We can hear you, sir.
Good. So I'm super excited to witness once again the Warri chapter technical meeting. It is my great pleasure to be here to welcome each and every one of us to this presentation. This is one avenue that NAPE has been imparting knowledge in all the members. We create opportunity for us to share ideas, best practices, collaborate with one another, and also network. You know, it's very key for us to connect with one another, especially in the area of professional development. So this is another opportunity for us to hear from an expert on some of the things that we need to know to support the business of oil and gas exploration. So I want to welcome every one of us to this technical presentation. It's going to be insightful, and I can assure you that at the end of this technical meeting, we'll have one or two things to take away. And this is opportunity also to ask questions, to interact virtually. And please always be rest assured that NAPE will continue to drive for policy that will shape the oil and gas business, and will continue the area of advocacy as much as we can. So thank you each and every one of us for always attending NAPE meetings, both in physical and also on the virtual platform. Thank you, and sit back as we listen to the speaker for today.
Thank you so much, Mr. President. Thank you. We appreciate you. Thank you so much. Next slide.
Okay. 1 minute. Okay, can you see my slide?
Today, need to help us. Let the slide go back to slide notes. Today, are you still there?
Yes, I'm there.
Okay, so help us. Let's go back to slide notes. Yeah, this slide. Can you help us again? You know, he was finding it difficult.
I don't have the presentation.
Okay.
Oh, you don't have it?
No, I
okay, wait. Just one minute. Let me forward it to President.
Okay.
Chapter Prof. Let me forward it.
To go to the next slide. Let me be reading our chairperson's profile before.
Okay.
Just go to the next slide. Why is doing that?
Okay, let me go to the next slide. I'm on it, chairperson, Ms. Doris Akbova. Yes, I'm on the slide now.
So the next slide, the profile. The next slide.
Okay, the profile. All right. Yeah.
The profile.
Sorry.
Okay, so Doris Akbova is a serial entrepreneur, geoscientist, and financial professional. She started her career as a geologist, age just 19, with Ashland Oil Company, and related and later joined Statoil, now Equinor, as a senior geophysicist. She obtained a BSc from the University of Port Harcourt, Nigeria, a master's in geophysics from the Imperial College, London, and an MBA from the University of Lagos, Nigeria. After a very successful and rewarding career working in Nigeria and Norway in various senior management positions, she decided to take early retirement to pursue other interests, which led her to learning about financial planning in the US. As a future forward thinker, she obtained her financial professional licenses, connected with several A-related financial institutions, and is now on a mission to educate her community with the necessary financial knowledge to plan a better financial future and fulfill their retirement goals and leave a legacy for their generation. In her early career as a geoscientist, she contributed to the discovery of oil and gas wells in Niger Delta by analyzing and interpreting geophysical and geological data. She was a member of the team that discovered the very first deepwater well, Oyo 1. She loves developing people and connecting them to resources. She's married to Dan Akpowa, an award-winning journalist and publisher of the Abuja FUPRE newspaper. They are blessed with 3 amazing children. So welcome, Dr. Doris Akpowa. Madam, over to you.
Thank you so much. I'm not doctor, but thank you. So what would I say? I'm really excited to be here, and I appreciate the call to serve NAPE. I'm available to serve our association at any point in time. So I'm super excited. And the topic in question is a great topic: predicting hydrocarbon source formation and stratigraphic complexities in the proximal deltas. An example from Eocene, Niger Delta Basin shale deposits. And we have the speaker, Dr. Jerry Osokpor. I hope I pronounced the name right. Dr. Jerry, is that correct? Osokpor? Can you hear me?
Osokpor, yes.
Okay.
Yes.
Yeah. So Dr. Jerry Osokpor is our speaker today, and is going to be presenting the topic that I just mentioned. And I believe it's going to be very instrumental and valuable for all of us to learn and take home some great nuggets. I'm super excited. I'm interested in learning about what he's going to be sharing. So I have my pen ready. I hope you all have your pens as well. So let's take notes and let's be ready to ask questions and gather as much knowledge as we can. Okay. So without much more talk, I would cede the floor to him. I don't know if I should be reading his profile, or Dr. Juliet, are you going to be doing that?
No, we are doing that. So you need to go to the next slide. Dr. J, go to the next slide.
Okay. All right. So Dr. Jerry Osokpor is an academic staff of the Federal University of Petroleum Resources, FUPRE, Niger Delta State, Nigeria. He obtained a certificate in stratigraphy, geochemistry, and reservoir and turbidite geology from the FUPRE Robertson Research Training Center, Landuno. Where is that? Dr. Osokpor, can you tell me, please, where is that? I just need to know. I don't know where. Is this spelled correctly? Or, I mean, I don't know if I'm the one that is Landuno.
Yes. It's a Welsh word. It's actually, if you pronounce it in English, you say Landuno, but as a Welsh word, it's called Llandudno.
Llandudno. Okay.
North
okay,
Wales.
Cool.
Yeah.
All right. North Wales, UK in 2011, and a PhD in petroleum geology in 2014, majoring in petroleum geochemistry and sequence stratigraphy. With over 15 years teaching and research experience, his research interest spans source rock geochemistry, clastic sedimentary systems, sequence and exploration stratigraphy, basin studies, and outcrop sedimentology. He has worked extensively on the sedimentary geology of most Nigerian basins and embarked on several field expeditions to the upper Benue Trough and Afikpo sub-basin of the lower Benue Trough. with a brief field expedition to the Pliocene and Pion and Uinta basins
Uinta
in
basins.
Colorado.
Yes.
Utah basins in Colorado and Utah, USA. Is a registered member of the Council of Mining, Engineering, and Geosciences, COMEG, and a member of several professional associations, including the Nigerian Mining and Geosciences Society, NMGS, Nigerian Association of Petroleum Explorationists, which is our association, and also the American Association of Petroleum Geologists, I believe. I can't see any more on the slide.
Geologist. Oh, okay. The slide is there.
So
maybe we
I
can try
believe that
to put it in presentation mode.
Okay.
Okay, so all right, so so ladies and gentlemen, I present to you our speaker for today, Dr. Jerry Osokpor.
Okay, thank you.
Jerry, please start.
Thank you. I'll be talking on the can you see my slide now? Professor Mudanugi, I've sent a copy to you, so you can forward it to our colleague there. Let him try to see whether I can do the gymnastics.
I've sent to him. I've sent to Tunde too.
Okay, let him anywhere whenever
he
he comes up.
Why he's trying to do that?
Yes, why he comes. Yes, okay, no problem. So I'll be talking on predicting hydrocarbon source formations and stratigraphic complexities in proximal deltas, with an example from the Niger Delta Eocene sediments. This is the abstract, which we'll skip for now. And there is my presentation outline. Yeah, as seen here.
Okay. Let me try to change the slide to my own.
Okay, no problem. Go ahead. And then now let's do a brief introduction. We are talking on deltas, and one may want to ask, what are deltas? Because sometimes it could be very confusing. People know deltas as a Niger Delta, but there's a geologic explanation and or consideration for deltas, geologic features or elements that are considered as deltas. These are geologic elements that have been variously defined as discrete shoreline protuberances that are formed where sediments, where rivers, mainly rivers, streams, transport and deposit or debauch their sediments in basinal areas such as maybe open oceans, coastlines, sheltered coastlines, bays, lakes, and some enclosed areas. Those are deltas. And because of the way they are formed, there are a lot of factors that are instrumental to their formation and how they evolve stratigraphically. Factors both continental and basinal factors are instrumental to the formation of deltas, which we don't want to delve in here because it's outside our scope. Now, these factors, depending on the way they interact, they interplay to determine how economic any deltaic sediment will be, mainly the transgressive, regressive activities of the ocean and how sediments are transported from the hinterland and deposited determines how the sediments are laid and the ultimate economic potential of that basin. In our local environment, we have the Anambra Basin, the Cretaceous Anambra Basin, back in the Niger Delta. You can see that the Anambra Basin is not as economical in terms of hydrocarbon resources as the Niger Delta basins. It is because of the way the factors, geologic factors interplayed to lay down the stratigraphy, which is instrumental to the evolution of that basin over time during the Cretaceous. That's why that basin is not as prolific like the Niger Delta. Let's look at the next slide. Now, talking about the Niger Delta, this study has been carried out. And one will want to ask, why was this study carried out? What's the justification for carrying out this work? Now, it is because of debate that has arisen, that has been on ground for over 4 decades on the source rock of the Niger Delta. People are still doubtful in some climes as to which is the actual source rock of the Niger Delta. And actually, this debate started as far back as I would say in the 60s. Yes, 60s and even 70s. Started when some gentlemen led by astute geologists looked at the Niger Delta and said, we think this is the source of the sediments, the oil in the Niger Delta. Yeah, all of this debate started, was led by authorities such as Frankel and Kadri in 1967, Short and Stubble in the 60s also, Reed 60s, and then you have people like Lambert, Akionbari in 1984, Akionbari and eBay also in 1984, Evermill, the Equazors and Okoyes in all of this era. And in this period, on the subject matter of the source sediments of the Niger Delta, two schools of thought exist. One school believes that the Akata is the sole source rock of the Niger Delta, while the other school believes that the Agbada is the source rock of the Niger Delta. Well, a third school may have a reason where they have seen that, well...
Excuse me, sorry, may I just cut in? Tunde, yes. I believe we shouldn't be on this slide. I think you need to go on further because we're still on the introductory slide.
Okay. All right. So I should move on?
Yeah.
Yeah. So all of these, they have looked at the source rock, and then the arguments have been raging. So the Akata formation has been reported to be overpressured by some authors, and because of that, people who feel that the school of thought who believes that the Akata is the sole source rock of the Niger Delta, they believe that if it has produced hydrocarbon, there's no way hydrocarbon could have migrated from that area because the conduits are closed by pressure at depth. Although recent studies, not too recent, although in 2009, this gentleman, Kobold and some folks discovered that the maturation has actually occurred and is ongoing in Niger Delta because of structures they found in seismic in that area. Now, the Niger Delta, as it were, was bettered by end Cretaceous tectonosedimentologic events that occurred in the distal part of the Benue Trough. And during this time, the KPG transgression took place that laid down the initial formation of the Niger Delta. Not too many people know that the Niger Delta has more than 3 formations, but actually the complexities in the delta is actually bettered by the initial stratigraphic template that was laid down in the Niger Delta. And in this period, the KPG transgression that took place ended in the early Eocene, that's what we call the Euprasian stage of the Eocene. And that's that period, beyond that period to the Oligocene, the 3 older formations of the Niger Delta were laid down, which is the Imo.
Sorry, Dr. Osokpor, I'm sorry to cut in again.
Yes.
I think you need to advise Tunde when he needs to change the slide because
okay, is Tunde there?
He's the one who wrote the slide.
When he's ready, just tell me.
No, you just tell him next slide, and then he will change because he won't know which slide you're talking on.
Oh, okay. Tunde, change. Tunde, can Tunde hear me? Change again.
Okay, I can hear you.
Change again. Okay.
So, Dr. J, when you're going to the next slide, just say next slide so it will be easy for you to change.
All right. So we are on this slide now. So this was bettered not to the earlier formation of the Niger Delta is not really popular among many students of the Niger Delta Basin. We have the older formations and we have the more recent formation, which is known popularly as the Akata, Agbada, and Benin formation. But actually, the complexities that you can get in the proximal part of the delta is a function of the initial stratigraphic signatures that are presented by the delta. All of these events that took place, the transgression and regressive events that took place in this area have been are the foundation, pivotal in the stratigraphic evolution of the source rocks and reservoir sediments of the Niger Delta Basin. And we have to understand that because the organics in the Niger Delta are mainly continental organics, it is well, how will I put it down? It determines the kind of petroleum, the kind of hydrocarbon that is sourced by the sediments. Next slide. Yeah, this is a regional map of the Niger Delta with the location here, Vona 1 well. The well from which the sediments samples were obtained for this study is pseudo-named Vona 1 for confidentiality purposes. Next slide. Yeah, this figure 2 here presents a stratigraphic deep section of the Niger Delta, Cenozoic Niger Delta, while our well is located in the proximal part of the delta, as shown here. Next slide. Let's look at some materials and research procedures that were used for this study. One minute, sorry. Okay. We have used composited and non-composited samples from certain depths within these, about 7.2 meters of core samples, and non-composited well-cutting samples that were drilled into the distal part, the proximal part of the delta. And what we did for initial analysis, organic carbon was determined, and further analysis was carried out using the rock-eval pyrolysis method as patented by Espitelia et al. 1977. In this, we used vitrinite data from the rock-eval was used to calculate vitrinite reflectance. The rock-eval 2 data sets were also used for further analysis and imputed into the equation by Jarvie 1988. Next slide. Still on analytical procedures, in order to be able to bring out certain cryptic data sets hidden in our sediments, we use the extent of petroleum generation, or what we call fractional conversion of organic matter methodology. This involves a mass balance equation that as shown in this slide here. All the parameters that are used for that is shown below here. Production index, initial production index, and the ultimate production index, original and measured. Next slide. So having done all of that, let's look at research outcome, or what we call results and interpretation. Now, this work is divided into 2 parts. A part of this well was cored. The data sets for this well are cored and well cutting samples. So what was done was, in order to get a good signature, a good signal, a geochemical signal, we had to, it was expedient that both sets are separated and analyzed separately. And then not this slide, next slide. Next slide. Now, table 1 on this slide shows you some of the data sets that are generated. These data sets on this table may not be of too much use to some of us until we make interpretation out of it. Next slide. This is a continuation of table 1, where all the parameters have measured. These are both primary and secondary rock-eval parameter and TOC values. Last slide. Are we there? Okay. Now, this table actually, table 2 presents the generation potential, because the first step in carrying out source rock analysis to find out whether these rocks actually are qualified for any further analysis, or to see whether they have the potential to generate, because there's a minimum requirement for TOC, minimum TOC requirement for any material to be considered as source rock. So this table displays the range we have for this very well, with their quantity from poor to excellent. This well has from good to excellent. And then we look at also the rock evil parameters, the S1, S2 values, and they're distributed in percentage here. Next slide. This is a summary of both the primary and derived rock evil data set also from this well. We'll come to these ones when we're discussing maturity, thermal maturity, and other parameters later on. We'll see the value of this. Next slide. Now, here in this slide, we look at the percentage distribution of organic materials in the cord section of this well. And as I said, it ranges from this low, good to excellent. All right. And we can see that 50% of the samples yielded excellent organic material that are that will be useful for production of hydrocarbon. Next slide. Now, the kerogen present in these samples were characterized using the hydrogen index value for each samples, which actually presents or explains the quality of the material, because beyond the quantity, quality is of utmost importance to know whether you'll be able to generate a substantial hydrocarbon. Now we have different hydrocarbon for different section of the well, where we have a range of 17 to 403 milligram hydrocarbon gram per TOC, with an average of that for the interval that was caught. These values actually indicate different types of kerogen, ranging from types 2 to type 3 kerogen in the samples. But in this section, there was a dominance of type 2 and type 3 kerogen. While we have, for the uncut section, we also have a dominance of or other kerogen species, as shown in the slide here. Now, the interesting thing about this well is that a section of this well showed maturity, while a section is immature. That's where it's going to get interesting. The section that has majorly type 3 kerogen, low quality kerogen, punctuated by type 2, type 3 in some stratigraphic levels, actually is matured, while the section that is not matured is dominated by type 2 kerogen, punctuated by type 2, type 3 kerogen and some stratigraphic intervals. Next slide. Now, all of the data sets that were generated from primary and secondary evaluations have been presented in this geochemical well log for the well. You can see on the far left, you see the hydrogen index value. Like what I was explaining in the previous slide, this section is the upper part of the well, all right, from the 2475.6 to less than 2480 is the upper part of the well, is the uncut section, while this area on pink at the base of the well is actually the data set from the cut section, where the rocks showed maturity, where thermal maturity has attained hydrocarbon generation state. So if we look at the other parameters, the organic carbon in the third column, we can see that the upper part also has high TOC value compared to the area on pink, while for hydrocarbon source potential, it also showed that the upper part of the well had higher potential compared to the lower part. We want to see why is this this is an anomaly to an extent. It's an anomaly initially when you look at it, it's an anomaly. But this is why we are trying to explain the cause of this anomaly that we see. If you look at this column again, the fifth column here, you see that for the oil prone, the upper part of the well had better oil prone. They have better hydrocarbon, liquid hydrocarbon. While if you go to the last column here, you see that they are not actually matured, but they have more potentials, but they're not matured. While the ones that are matured has lower potentials. Next slide. Now, in order to describe the source kerogen type, we've used this pseudo Van Creveld diagram to type our kerogen and actually see where they fall. Well, you notice that there's a concentration of these materials within the type 3, the gas-prone region, with few scattered samples within the type 2, type 3 area. That's the oil and gas-prone the regions of this Van Creveld diagram. Yeah, all the samples actually concentrated within this area. All right, within this area. And this has also been seen in other studies for the Niger Delta samples, previous studies by myself and some other colleagues and some other renowned authors. Next slide. Now, as I said, in order to do vitrinite reflectance analysis, the petrographic methodology is normally used, but the rapid method that we adopt is to use rock eval pyrolysis data to calculate for vitrinite reflectance. All this has been widely criticized by many authors, but it is still a very valid method for quick, rapid analysis, rapid evaluation of source rock for basin evaluation. So we can see that in the first diagram, in the diagram A here, it's depth versus reflectance that is calculated here. And we can see that at the stage, all of these samples entered into peak maturity. Okay, so the samples actually range from immature to maturity, to peak maturity. That's what the samples attained for this well, so at the lower level, while the upper level actually attained some level of early maturity and immaturity. And you can see that for peak maturity, this is 0.8 vitrinite reflectance, while 7 actually is matured. Next slide. Now, two conditions have been erected for this well to explain the anomalous occurrence of the parameters obtained for this well. Now, one is, let's look at the original potential of the materials, of the total organic carbon. There is what we call original potential and depleted potential, which we actually call measured potential. Original potential is that potential that the rock has when it has not produced, it has not matured and generated and expelled hydrocarbon. That is what it is. And many rocks that have not been matured will have higher potential because they have not expelled hydrocarbon. Now, the values of these TOC in rocks are ordinary for original potential is normally higher than the values that you have when the rock has become matured and expelled hydrocarbon. Yes, because when these materials have been matured, the hydrocarbon is, the organic matter is converted into petroleum, all right, and expelled away. So you have a reduced total organic carbon in that rock, all right. So in this well under review, there was a marked reduction in the value of the hydrogen potential from some depths to from a depth to another depth, which is actually within the oil generating window of the well, within the cored interval. Actually, this trend indicates that the HI values are based on the remaining potentials of that rock and not the initial potential, what we call the original potential, depicted as S2 naught. If we check the next figure, we'll see what we're trying to say. Now, looking at this, we know that the Akata formation, next slide, the Akata formation is a material that's been, as sediments are deposited in deep marine settings, while the Agbada is paralic. Hence, the Akata ordinarily is supposed to host type 2 kerogen, while the Agbada will host type 3, dominated by type 3 and even type 4 kerogen, with maybe some stratigraphic levels presenting subsidial type 2 kerogen. But you see, if you look at the well section, our data sets generated, it showed that the lower part of the well that has matured has dominantly type 3 kerogen. Why? It is so we are thinking that these values are presented because the material has generated and expelled hydrocarbon, so the potential has thereby dropped. What we measure is not what it actually is. So when we plot the values of HI against S2, S3 in this diagram, we can see that the materials, the true nature of the sediments of the rocks have been shown here within oil zone. Type 3 kerogen are not known to be very oil prone. They are oil and gas prone. But if you look at our diagram here, you see that just few samples falls within the oil and gas prone zone, while one is gas zone. This is actually an outlier. Now, the majority falls within this, and this is a reflection of the true potential of the sediment. So say that type 3 kerogen signature species that we are evaluating with the HI is actually not what it actually is. Until you do further analysis, you will not get this signal from that. Next slide. Still on that, in order to strengthen our position on the previous slide, we look at the trends that we have noticed above and see and try to make further analysis. We are thinking that there's a probability that the values measured from the kerogen types within the oil generating window were actually originally lipid rich as stated above. So when we do this analysis, looking at the fractional conversion of organic matter within that area, we have an average of 60.2% conversion for the wells. Actually, it ranges from 48.25 to 68.19 percentage conversion. And this is shown in this graph at different stratigraphic level for the well, that this is the signature presented. It goes to show that over 60%, most cases, an average of 60% of the original potential has been used to generate hydrocarbon. So you can see that the percentage remaining ranges from maybe 52 to 40 something percent, and that is why we say it gives us a signature of gas prone kerogen, whereas actually the original nature is suppressed because it has released its carbon content in the generated hydrocarbon. Okay, now so it shows that substantial volume of the original material has been changed with just the remnant that we measured in our data. Next slide. Now, when we look at this graph, it is not, it's not a steady graph that goes all the way down. It is like a wiggle. It is anomalous. It presents an anomalous pattern. So this is because of other factors that this pattern could be due to other factors that affect what do you call it? Source rock, as it were, the convertibility of kerogen to hydrocarbon, because because different types of organic material have different convertibilities, and also there could be stratigraphic variability because organic matter in all stratigraphic horizons are not the same. That leads to heterogeneity and some other variables that are beyond the scope of this this presentation. Next slide. So if we have looked at that original potential, let's look at other factors that may lead to this anomalous pattern that we have observed in this well. Is it that there's a stratigraphic abnormality somewhere in the interface between the two formations, in the contact between the Agbada and Akata formation, or are we dealing with a stratigraphic variability within one formation? What are we looking at? Is it a stratigraphic wedge in the form of intertonguing, which is actually lateral juxtaposition in the lateral dimension, lateral axis of the formation? Let's look at it. Because actually stratigraphic wedges are features that are common in geologic settings, especially within sequences. Next slide. Are you there? Are we in figure 9? Hello?
Yes.
Okay.
Yeah,
Okay.
figure 9.
Okay. Because I'm using my, okay, beautiful. Now, if we look at figure 9, this figure 9 actually presents a schematic stratigraphic model of the formations of the Niger Delta, showing the boundaries of the Akata and Agbada formation. It's, as you can see from the legend below, the Benin, Agbada, and Akata at the base. Now, we are saying that, okay, we know that the Agbada formation presents mainly type 3 kerogen, gas prone. Gas, mainly gas. It has more potential to produce gas and less potential to produce oil. Yeah, while the Agbada Akata is oil prone, mainly oil prone. Okay, now, so what may have been the trend? In the well, we see that the upper section has type 2, while the lower section have that's an overtone. What is supposed to be found in the Akata is what is found in the Agbada. What is supposed to be found in the Agbada is what we find in the Akata. So we are saying that, okay, let's look at it. Could it have been caused by these stratigraphic signatures that are presented here in the model? Because if you look at it, here we have, if you look at the diagram C at the base, in the oil generating with the base of this diagram C, you see the OGW. If you look at a type here, you see that you have mainly type 3 punctuated by type 2, type 3 punctuated by type 3 in some stratigraphic levels, while the top of the well has mainly type 2 punctuated in very few places by type 2, type 3 kerogen, which has higher potential. So what are we looking at? Is it that the Akata is on top and the Agbada is beneath because of this intertonguing? So this is what this diagram is trying to do. This is a model we have erected using this geochemical data set. Next slide. So that is that for the cut session. So let's look at the data set from the uncored section of the well, which is the stratigraphic interval. Yeah, this interval is above the cut session, and it's the first. There are two uncut sessions because the cut session is in between the two uncut sessions. The top of this well has presented Tmax range of 421 to 434, while the interval below that also presented a Tmax range of 427 to 438. Now, with a standard deviation of 3.7 degrees as an average and a Tmax average of 232. Now, if we actually the maturity, if you look at the intervals below the core section, it has a Tmax range up to 438, which actually shows that it has generated, it has matured, it has entered into maturity window. Yeah, 435 is the benchmark, is popular benchmark. But you see, we cannot hold fast to that. If you see the work of Moko Pade et al. 1995, when he worked on organic materials from source rock in a basin in Canada, this author found out that at 430 degrees centigrade, the rocks have entered into maturity. They have generated and expelled hydrocarbon. So he uses that as his standard. So it goes to show that the maturity, the convertibility of kerosene is a function of the type of kerosene. So this is as opposed to the 435 that is popularly known, used by many explorationists and researchers. So if we superimpose this 430 on this well, for instance, you discover that the major part of this well has actually entered into maturity, into hydrocarbon generation zone, the OGW. So it goes beyond the cut section. The cut section showed that it has entered properly because the material is not contaminated. The ditch cutting session, where we have ditch cutting, they have been contaminated, and so the signatures have been obliterated to an extent. Next slide. Now, this is the data for the uncut session. It's supposed to be table 4, sorry. Go on. Next slide. And next slide. Now, for us to be sure that what we are looking at, are you in figure 10? I'm using my slide. Are you in figure 10?
Yes, I am.
Good. For us to be sure that what we have been looking at, we have to do further verification. We have to cross-plot the reflectance equivalent data sets with Tmax for the well session. And a great correlation was achieved with this. It goes to show that, yes, it's somebody will say, why is it that perfect? Why is it a straight line graph? It can only be a straight line graph if the data sets are correct. If what the reflectance equivalence is showing you is corresponds, if it corresponds and correlates with the actual maturity for that stratigraphic level, then you're going to have a correction. This was done after some other renowned works have been published. Next slide. Yeah, in order to look at the production yield, all right, of this well, we have to to look at the potential, further potential of this material. We want to look at the production yield versus the total organic content of the well. Now, this will help us to put paid to the generating potential of the samples. If we look at it, you see that for the uncut session, the samples are mainly good, show that they have very great potentials, good yield. While for the cut session, it entered into the very good to excellent range. Now, still on what I said in previous slide, it's good here because it would have also been falling within these domains if not for contamination and mixture, contamination by drilling fluid and source rock material sediments during drilling. Yes, so that's what this slide is trying to tell us tell the story of this well. Now, we have looked at this well very well based on the data sets that we have used to evaluate the stratigraphic abnormality. We have seen that hydrocarbon the well had good hydrocarbon production potential. Now the question is it from the Akata formation or is it from the Agbada formation? What are we actually looking at? Now, the data set has shown us this, and it has suggested that yes, the sediments actually produced, have matured, and they have even generated hydrocarbon. Now it's for us to look for where the hydrocarbon is. Was the hydrocarbon produced sufficient to saturate the reservoir sediments within that area? That's a question to be answered. Now, we know that marine and terrestrial kerogen types are present in this well. From this analysis, we have seen that we have both the type 2, type 3, and type 3, and even type 4 kerogen within these this well, although these have been obtained from different stratigraphic intervals. Now, the areas that presented marine organic matter are immature, while those areas that presented terrestrial materials are matured. But we know that these signatures that are presented, especially in the lower part of this well, is actually false. We have elucidated why they seem to present that material. Although distribution pattern of this, the maturation, this suggests stratigraphic complexities, as expected at the transition between both formations, it may be related to all the factors we discussed above. Okay, and then lastly, contrary to views that if we dwelt on the opening section very well, where we have two different schools of thought, where one thinks that Qatar is exclusively the materials, the source material for the Niger Delta, while the other school of thought felt that it was exclusively the Agbada. We have seen that, and the one school of thought believes that petroleum generation cannot be possible in shallower depths, except you get to 2,500 meters below the surface. This well has shown that production, generation, and migration of hydrocarbon at stratigraphic levels well above 2,500 meters from the surface is possible in this area. And this is made possible because we're looking at the age of these sediments. The Niger Delta age is diachronous. It has different age at different parts, and even up till now, the Niger Delta Basin is still forming, as long as the Niger River Benue system is still transporting sediments from the hinterland and depositing them in the offshore. The delta is still building. This place takes us back to the conditionalities required for hydrocarbon generation. If you look at the model of Lopatin, the TTI Lopatin model in 1971, which looks at time is of utmost importance in hydrocarbon generation. The proximal part of the Niger Delta is older than the distal part and the medial part of the delta. So these materials, although the thickness is not as much as what is expected, but with the time of maturation, they have been exposed to geothermal stress for longer period, so they are bound to have matured at even shallower stratigraphic intervals. So the Agbada is considered to be of paralic origin, while the Akata is of deep marine origin. But the results from this study has shown that the Agbada in this study location is actually, if the upper part of this well is Agbada, if anything to go by, or if the lower part of the well there was a stratigraphic overturn, if the Agbada was stratigraphic overturn, it is actually immature at this location, while the Akata has been seen to have sourced, is mature, have seen to have sourced hydrocarbon in this area. So consequently, these findings that we have seen here has also lend a voice. It's logical. Lend a voice to the uncertainty surrounding the source sediments of the Niger Delta Basin. But what I want to say is that we have done so many works in other areas where we have seen that the Akata is actually more matured, while the upper part of the Akata is barely matured. So if the upper part of the Akata is barely matured, we do not think that the the upper part, which is the Agbada, would have entered any form of maturity. Because if you look at the work of previous authors that worked on this, they have seen that the shales of the Agbada formations are not stratigraphically thick enough to produce, to source the volume of hydrocarbon we have in the Niger Delta Basin. That if for anything they have sourced hydrocarbon, it should be
sorry
just.
to interrupt you, Jerry. Osokpor. Are we on the right slide, or does he need to move the slide?
Let me see. Yes. Oh, sorry, I didn't tell him to move this slide. Move the slide. Sorry. Move the slide. Move the slide. We're the conclusion slide. Has he moved it? Okay, go to the next one. Next. Okay. Yeah. So okay. So yes. So the sediments of the Agbada formation is not stratigraphically thick enough to source the volume of hydrocarbon, liquid hydrocarbon we have in the Niger Delta Basin. And so this work actually stands for the Akata formation, sourcing the being matured in this part of the Niger Delta Basin, while other studies continue to go. Next slide. This work, next slide, yes, this work has actually been published, was published in 2023 as the original title, The Pattern of Organic Matter Type Occurrence and Distribution in Predicting Hydrocarbon Source Formation. An example from Eocene Niger Delta Basin. It was published in the Journal of Sedimentary Environments. Journal of Sedimentary Environment is a Scopus rated journal and A-rated journal of earth science. Next slide. We have come to the end of this presentation. Thank you very much for your time. Thank you for listening. God bless you.
Thank you so much, Dr. Jerry Osokpor. This is a great presentation, an excellent one. You guys have done great job with this analysis and the results that you have come up with. I think it's quite instrumental to the understanding of what sediments are doing, when you have juxtaposition going on and all that. Sometimes it can be a little bit confusing, like you presented, what are you looking at? So you need to obviously look at a bit more data, even outside of the well location, to see what is happening in the area of the layering and the stratigraphic patterns that come across that. But before that, let me just quickly summarize what I think I heard you say. You started the presentation basically, explanation of what deltas are and the differences of the different deltas, to give a foundation of that is understanding. You talked about the continental and basinal factors that influence the formation of the deltas and why that makes a difference, because of course if it's a regressive sequence or transgressive sequence, it makes a difference on the kind of sediments and the layering of those sediments. You talked about the reason why the Anambra Basin, is not prolific, again, because of these factors that you mentioned, so comparing the Anambra Basin to the Niger Delta Basin, we all know that the Niger Delta Basin is where we're all exploring from, and that's where we're getting the results, that's because of the positional patterns and this. Can you guys hear me?
Yes.
Okay. All right. So
yes, we can hear you.
Okay. So basically, we're trying to justify the study, and why the Akata, is the source rock that we've all known for many years as a standard. I like the fact that, you brought to the front burner, a lot of the studies that have been done by some of our own people. You mentioned Dr. Moshala, you mentioned Dr. Lambert, and these are people that we know and see every day. So it's good to see that, their work is being used and expanded upon. So yeah, you mentioned the Niger Delta, the type of hydrocarbon based on the study of the well, that you looked at, the total hydrocarbon count being, less than 5 as poor, and when it is over 4, you see that as you consider that as excellent, and you categorize the various kerogen, okay, the low quality kerogen, you call that the type 3. And that's basically because those are like linked to gas, and the higher quality ones, you see that as type 2, which is more linked to oil, oil kind of prone areas. In your core, you said that you had some cored sections and uncored sections, okay? And the upper part of the well, I believe, was the uncored one, if I heard you correctly. And the hydrocarbon content in those areas were higher compared to the lower part, which was the cored section of the well. Let's see, what else did I take notes of? And in trying to explain the anomaly, one of these things you're looking at is maybe, it's got to do with intertonguing of the sediment. And that may be the reason why you expect, what you're expecting on the upper part of the well is different from the results that you've got in the lower part of the well. And I think that could be a good explanation as well, But I have a question. I was going to ask, have you looked at the well? I don't know, I don't know if there was any well outside of that area, but have you looked at maybe like a well a little bit distant from there to see whether you still maintain the same anomaly pattern? That way, you can maybe be able to draw on your analogy that it could be the same thing happening, because I noticed that in the well that you showed, the intertonguing was basically leading, like maybe dying, going to the other part of the well. So if you had a well drilled on that part, on the other side, I don't know whether it's west or east because I don't have it in front of me, but then maybe to see what happens on that side, to draw the conclusion on the fact that it could be something related to intertonguing, or if it could be just the fact that it's just immaturity of the hydrocarbon that you're seeing in that area. So, I mean, if you could maybe throw a little bit more light on that.
Yeah, yes. There's a work that was carried out by myself and Overa. This work was done in 2019 from the same area. What we saw was published in the Journal of Mining and Geology, the NNGS journal. This this anomalous stratigraphic signature was not found in that well, but in that same well, we noticed that we were able to delineate that well to an into upper and lower. The upper part of the well was actually Agbada formation, while the lower part is Akata formation. The upper part of the well, which is the Agbada, has not produced hydrocarbon, is not matured, while the lower part showed signatures from the lower part showed distinctively clearly that the sediments were matured. We had up to the vitreous reflectors are up to 7.1, which is very good maturity in that well. And actually, in that part of the well, that well actually struck the sediments from that well are from older wells that were drilled in the upper part, proximal part of the delta. It entered into Eocene, and we from previous studies, also from the samples, we saw that the lower part of this well presented Paleocene and even late Maastrichtian bio signals. And this actually are the sections that are matured, the Eocene to the late Cretaceous to Paleocene, because actually it's close to the basement. So we should expect older sediments. These are the ones that are matured. While the Oligocene section which is actually the Oligocene Miocene section, were actually immatured, which is the Agbada Formation were immatured.
Okay. Well, that's good that you've looked at that. Okay, thank you so much. At this point, I'd like to throw the floor, open the question to the floor, and then if you have a question, could you maybe unmute or just signify by raising your hand on your Zoom device so I can see your hand up? I guess
there's a question in the question box.
Are there people who are in person or everybody's on Zoom?
Everybody's on Zoom. It's fully virtual.
Okay.
Okay, there's a question so let me read that so you can take that. Okay. Dr. J. Okay. There's a question from Dr. Christopher Iwobi. So did you have the wireline logs to correlate this well with other wells in the same depot bed? This will probably help you solve the stratigraphic conundrum. It is known that within the Agbada Formation, there are also transgressive shales, that is marine, which could display type 2 corrosion. So did you do that? That's always trying to ask.
Yes, in previous studies, we have looked at the wireline log for these wells. You see, when you're talking about transgressive shales, you see, and that brings about the intertonguing, transgressive, regressive stuff. You see, the contact of the Agbada-Akata formation is not a straight jacket. There's a complexity there. It's not a straight jacket contact. All right, there's a transgression, there's a regression, there's a transgression, there's a regression. You see, and while the stratigraphic package is being built, is building up. Okay, so when you have transgressive shale within the Agbada Formation, those transgressive shales are those shales that some authors believe have generated hydrocarbon for the Niger Delta Basin. But studies have shown that even these transgressive shales are not thick enough to source the volume of hydrocarbon, because when we do mass balance calculations, they are not thick enough to generate the volume of liquid hydrocarbon we have in Niger Delta. And you look at their thermal maturity status, they are not thermally matured. So the argument that the school of thought who is posing for the Agbada Formation is that the Akata Formation, even if it's matured, cannot expel hydrocarbon because of overpressure at great depths. But studies with the same seismic by Kobold et al. 2009 has shown clearly with seismic very elucidating studies has shown that hydrocarbon is migrating. They have shown structures, clear structures with seismic that hydrocarbon is migrating from the Akata Formation into the reservoirs of the Agbada formation. Yeah. I don't know if that answers Iwobi's question.
Yeah. Does that answer your question, Dr. Iwobi? Okay, I don't get anything from him, so I assume it is answered. I have somebody raising their hand, Oladotun Oluwajana. Please go ahead and ask your question.
All right, good afternoon. Good work done by Dr. Jerry Osokpor. I have contribution. I listened to part of the presentation, not all, and able to put down some parameters which seems the presenter need to look at. A T-max of 430 generally suggests early maturity. And also want to say that T-max depends on the kerogen type. Pegging or setting thresholds for T-max is dependent on the kerogen type. The presenter needs to know that. Also, TOC greater than 8 weight percent. The presenter needs to look at this value. It's high and could be that chord section could be a Coley section. I'm saying this because I have several publications in Niger Delta, and I must also acknowledge the comment of Mrs. Doris Apoa about the need to look at the spread in Niger Delta. It's very complex. Presently, I'm looking at Akata 1 well. I have geochemical data. and I've seen values from that particular well different from studies I published on Umutu 1, Oben 1, which are of Eocene age. As also the presenter need to also look at the spread, looking outside a particular area. I guess it's looking at northwestern area of Niger Delta. Also, lastly, palynological study is very key. Based on your results, what I'm just saying is just a need to look at a palynological studies of the section under the core section. The core section, I think you need to look at palynological studies in order to be very sure if you are looking at the proximal part of the delta or you are looking at the distal part of the delta. Those are my comments. Thank you. Well done, Dr.
Thank you
Gerald.
very much. I would like to respond to this comment. Yes, so that we're without wasting time. Actually, see, we have carried out several studies. If you look at my work online, we've carried out several studies on biostratigraphy using palynology for different parts of the delta, from the proximal to the medial to the distal parts of the delta. And we have consistently seen that. In fact, there was a time we felt that the lower parts of most wells actually falls into Paleocene, but we are not too sure. We are not so confident because you cannot really determine reworked polynomial the way you determine reworked forams. So we are thinking that they are reworked actually from the proximal part of the delta, especially once we see in the medial to distal part of the delta. Yes. Talking about other wells, as I said initially, I've done that. And in response to what you said, we have also done work around these areas to look at the signatures from these wells around before we came out to say, okay, initially, when you look at something, you'll not be too sure. Yeah, we have looked at results from these areas and seen that it's time to come out to speak, to tell you this is what we think we're seeing. Yes, I've done that.
Thank you so much for your response. There's another question, another hand up, Brume or Varere.
Yes.
Brume, go ahead, please.
Hello?
Yes.
Hello?
Yeah, hello. Hear you. Go ahead.
Okay, thank you. Yes, Dr. Jerry, I joined late. Thank you for the opportunity to ask this question. I know I have done some works with you, but I just want to mention that Ejedawe et al., 1984, particularly, I'm very particular about that publication. He worked in the central part of the delta and was able to discover that the hydrocarbon generation and expulsion from that lower part of the Agbada formation predate the cessation of the subsidence and structural deformation, whereas in other parts it postdates cessation of subsidence and structural deformation. So, in summary, based on his research, he was able to find out that in that central part, in the central part of the Agbada formation, and so in the central part of the Niger Delta, rather, not the Agbada formation, in that central part of the basin, that the Agbada shales contains has been able to generate significant amount of hydrocarbon, that could be part of what is considered as the source of the hydrocarbon in the Niger Delta. And specifically, he also said that the source should not be tied to just the kerogen type, that the thermal conditions also influence the oil mix. So now, based on that study from Ejedawe, I know I have done some work with you, but I don't want us to just like throw away the fact that it is possible that in some part of the Niger Delta, if we can do a reevaluation of those areas where Ejedawe worked, and see whether some of those things are there, and then we can reconsider our thought and not just throw like it is entirely from the Akata shales, the source hydrocarbon in the Niger Delta.
Okay, thank you, Mr. Brume. You see, like what Oladotu said, there's a question, there's a comment he made. Actually escaped me. So your question has reverberated it in my mind. You know, was talking about maturation at 430. That 430 is early maturity. The popular maturity is 435. I made mention of Mokupade 1995 in the Canadian Basin, working on organic fishes in the Canadian Basin 1995, that found out that the sediments were matured at 430. All right, 430 degrees and then I also mentioned in my presentation about kerogen convertibilities. Different kerogen species mature at different temperature depending on the type of organic matter. Type 2 kerogen, you know, if we go into kerogen, what do you call it, nomenclature, kerogen is beyond type 2, type 1, type 2, type 3, type 4. We have type 2A, type 2B, depending on the sulfur content, the hydrogen lipid content, depending on where they are sourced, the kind of material they are sourced from. We need to talk about sapropelic, tobanite. We go into source rock petrography. We don't want to go there. It's beyond the scope of this work. So now, what Ejedawe said, Ejedawe and what's the name? Ejedawe and Oko 1981, Ejedawe et al. 1984, they actually saw what you are saying. And they said that, yes, it is possible that the Akata and the Agbada has contributed, but they have different level of contribution to the hydrocarbon resources of the Niger Delta Basin. We have consistently said in our work, we have not said that no, it is only when we conclude, we say that from this part of this area of the Niger Delta that our study is restricted to, this is what we have found. We cannot, it will be spurious for us to generalize, to say that because we found this there, then it's everywhere the same. No, that would be wrong. That you don't extrapolate with one well and extrapolate for Niger Delta. The Niger Delta Basin is a very complex basin. See, deltas have different stratigraphies. Deltas that are formed in huge lakes. If you look at the deltas that are formed in the Pions Uinta Basin, for instance, in Colorado, see they have the model delta stratigraphy of Barrel 1912, where you have the bottom set, the top set, and the first set. Yes, in Niger Delta, we say the Akata, Agbada, and Benin are the bottom, the first set, and the top set. But if you go into the nitty-gritty of the stratigraphy of the Niger Delta, you discover that it's very complex. It's more complex. If you look at sequence stratigraphy sessions of the Niger Delta, if you look at where you see the complexities, you are exposed to data sets from Niger Delta. You see, that it's very complex. It's more complex than than the what do you call it? The three tripartite delta structure that is known. Those are just models. The Niger Delta is more complex because what do you call it? Basinal factors. All right, the factors that engineer the evolution of the sedimentary pile act in different ways in different times. They are controlled by external factors, all right, at different times and stages and ages of the delta evolution. So that is what that's what's on board. Yes, it's more complex than we think. Yeah.
Yeah, thank you so much, Dr. Osokpor. This has been a very useful and informative session. I believe a lot of people here got a lot of value from it. I think our time is fast spent. We had about 10 minutes for questions, and we've kind of overshot that. So I would be asking for more questions. I just want to say thank you for the good delivery, and thank you for the responses that you gave and the answers. You know, they were quite succinct, and I want to wish you all the best as you go on with your work.
Thank you very much.
Yeah, thank you. So at this point, I think I'm going to be passing it back to Dr. Gillett to I think it was supposed to be the president who is to take over. But I believe my job as the chair is finished. Thank you.
Okay, thank you so much, man. Thank you so much. We appreciate you.
Thank you.
I appreciate you, brother. So over to the president-elect.
Okay, thank you very much, my Warri chapter coordinator. Can you hear me, Prof?
Yes, I can hear you. Thank you.
Okay. Unfortunately, I wanted to show my face, but for some reason, I cannot activate the video. But it's good that you're hearing me very well.
But your picture is showing. Your picture is showing already.
Okay, it is still me that is talking. No worries. Thank you very much. Again, quite excited, right, to listen to this topic today. And
Sorry, you
thanks
can
to
go
our
ahead and activate your video, sir.
Okay.
Are you sure I still want to show my face at
No, show your face. Let's see. Okay, hey, yeah, fine. We can see you now.
Let's see your face, RP. Let's see your face, please.
No worries. Thank you very much. So I really want to say thank you very much, Dr. Jerry.
Thank you, sir.
Thank you for all the, again, all those that asked the questions, and our chair, our own Doris, for managing the session, and all the chapter executives being led by our able Professor Juliet as the chapter coordinator. So what I want to do right now is our tradition to appreciate you, Dr. Jerry, for this insight you've shared with this community, NAPE community. This is a technical community, and you have indeed shown quite robust technical knowledge with this audience. And therefore, on this note, on behalf of the Executive Committee of NAPE, the Board of Trustees and the Advisory Council and entire members, again, strongly backed by our Warri chapter coordinator, executive and members, I really want to present this virtual award of appreciation for being the speaker for the month of March technical meeting for Warri chapter. And therefore, congratulations for this. And I do expect that this paper you have actually presented today will find its way to our NAPE conference coming in November. So just dust it up and then submit your abstract so that it will also be presented to a wider audience. But for today, I really want to say congratulations, and we now officially hand the plaque virtually to you. Congratulations,
Thank you,
Dr. Jerry.
sir. Bless you. Thank you, sir.
Thank you very much.
Okay, thank you, my PA. Thank you so much. So, Dr. Jerry, anytime you are back to Nigeria, you get your physical plug.
Yes, ma'am.
Yes, so just plan to fly in November. When you come in for the conference, then you will get your plug.
Thank you.
Right.
Okay, so we're going to our announcements. Mr. Iwu, are you there?
Yes, ma'am. Good evening, all.
Okay, so,
good evening.
Good evening, the guest speaker. Good evening, my president and my president-elect, my chapter coordinator, and their panelists. The announcements. This our next NAPE Warri. We urge you all to kindly mark your calendar for April 16th for our next technical and technical section. Next slide, please.
It's going to be hybrid. It's going to be hybrid.
Yes, it's going to be a hybrid too. Then 2024 NAPE Annual International Conference and Exhibition. We urge you all to kindly mark your date and get set. The date is November 10th to 14th, 2024. Next slide. Yeah, still on the conference. The theme of the conference is resolving the Nigerian energy.
Please don't leave the call. Just don't leave the call. We'll take a group photograph. Please don't exit yet.
Okay.
Go ahead.
Okay. Energy security, sustainable growth, and affordability. The date for the conference, November 12th to 16th, 2024. Venice Eco Hotel as.
Taloke, are you there? Are you there? Okay. So it's like network has bounced him out. So
yes.
The call for abstract is open.
Yes.
Let's endeavor to send in our abstract. I'm sure as NAPE members we have received these messages and we have the link and all that to do the needful. I will see November.
So next slide, please. Next slide, please.
Lucky, are you there? It's like you're having network issues. So let me just take it from here. Can anyone hear me?
Yeah, we can hear you.
Okay. So our exhibition floor is open for companies to reserve their space and for anyone, so even for academic, for institution also. So please endeavor to reach out to your companies and all that, and let them be able to reserve their space. It's very important that your company is involved and your institution is also involved. So this is our conference team.
Yeah, our conference team, resolving the energy trilemma, energy security, sustainability, growth, and affordability. Yeah, the website for registration is there. Then we urge you all to pay your dues, and that's what qualifies and makes you a member of NAPE, of this great association. The dues, the bank details are there, and the contacts too are there. If you have challenges, help me meet any of the chapter executives. Next slide, please. Yeah, our monthly technical meeting sponsorship opportunity is open. And these are avenues in which you can promote your company and sponsor opportunity. Next slide. Yeah, membership dues. The rates are stipulated: student membership, active membership, and associate members, and corporate members. So we urge you all to renew to pay your dues. The association.
Oh, you have done this. This is repeated already.
Yeah, this one will be repeated. Okay. Group photograph.
So can on our videos, let's say, Tunde, help us with the group photograph. Can we on our video? Tunde, are you there? My president, are you there? My P.
Yeah, I'm here. I changed my device, but it looks like Tunde, can you activate me again now? I changed it.
Brume, activate your video.
Okay, you can go ahead.
UK Europe coordinator. EIC.
It's not allowing me to join with video.
Yeah, EIC is available here. Good day, ma'am.
Today, thank you for joining us. Thank you. Today, activate everybody. It's like
today not be join in time.
Oh yes, okay. You can join the video.
Please. Oh, activate for Brume. Brume, are you there? Dr.
Yes,
Brume, are you there?
I'm here.
Okay, so you activate. Let's see your face. We've not seen your face in how many years?
See my master, Dr. Iwobi.
Oh.
Jerry,
hello, sir. Sir.
How are you?
Fine, I lost your contact. I lost your contact.
You lost my contact. Okay, you can get it from your chapter coordinator.
Exactly.
You get my master, not Jesus.
Why not? Okay, let's take the.
Before we take, I must tell you what this
the president is not on yet. So activate for president. We can't take the video without president. We'll be fine.
he was a lifeline to us in the UK in 2011.
Oh, that is fine.
Okay, maybe the president.
Are you there?
Maybe the president is not available. His video is
not available. Okay. So do the snapshot so we don't waste much time.
Is my picture showing? Am I showing?
We are seeing you.
We can see you
from the water sides.
Okay.
You can.
Mine has not been activated, so it's not my fault if I don't show.
Oh, just hold on. Tunde, Dr. Brume says it's not activated.
Okay, hold on.
So, can Brume activate now?
Okay, Brume can activate now.
So, Brume, do that.
Okay.
Hey, Dr. Brume, see your eye. After like 5 years or 4 years. That is nice. Okay, today you can go on.
Okay, it's done.
Take it again. Oh, are you sure?
It's done, yeah.
Okay. So thank you so much. Thank you, everyone.
Thank you.
Deputy Coordinator, are you there? Is our Deputy Coordinator there? Oh, she is not there. It's not there. Okay, so let our P gives appreciate everyone at least for P. Hello, P.
Good. Can you hear me very well?
Yes, we can hear you. So do a vote of thanks for
thank
us.
You. No, thank
on
you
behalf
very
of
much. No, I had to really stay back here because of the love I have for this chapter, right? I'm running late for something, but
thank you.
But it tells you that this chapter, I mean, Warri is when you talk about oil and gas industry, right? You cannot talk about oil and gas industry in Nigeria, about Niger Delta, without talking about Warri. And therefore, what you've done today is just to demonstrate that indeed the hardcore and the foundation of geology has to emanate from the core of the Delta, which is, Warri as is as well. So on that note, I want to say big thank you to the Warri chapter for keeping the flag flying, and to also encourage your ESCO as well, right? It's not easy. It's not, juggling our work and serving and volunteering for NAPE. Just continue to do it. It's just expanding the knowledge. Volunteering also comes in with its own reward. And for every single one that is still on the call, thanks for staying focused, because if you don't have the foundation around the technical, whatever you do in business and leadership, you will be weak. So you're doing the right thing by staying connected. So I can only encourage you to continue to do this. And then for our chairperson for today, who is also a fellow of the association, former Vice President Doris Aboa, we really want to say thank you. Even with the difference in time zone, being able to still coordinate this. Again, Juliet, our own prof, you've been leading quite well, and you get the much more support you need with your ESCO. And for the presenter, the speaker yourself, Dr. Jerry, again, thanks. And let's have more of you and some of these things being shared with our knowledge. I can also see Solidarity, our UK Europe chapter coordinator, Dr. will be supporting this. Our EIC, I'm sure our EIC usually joins this session to ensure that all the technical presentations are find their way to the conference. So that's why he's here. So he's taking notes. So, but on that note, I really want to say thank you everybody for staying tuned and for the robust discussion we've had this afternoon. And in April is another date, so make sure you dial in again. It will even be greater. So on that note, thank you very much. And we can network a bit now before we formally close. Back to you, Professor.
Thank you so much. Thank you, P. Thank you. So thank you, everyone. Thank you so much. We appreciate you.
Thank you all.
Thank you. Madam Doris, thank you for the short notice that you came aboard. Thank you so much.
Dr. Jerry, well done.